So the next quantity we will be talking about in relation to kinematics is acceleration. By definition, acceleration is the rate of change of velocity, and since velocity is a vector quantity, a change can be in either magnitude or direction. It can also be both change in magnitude and direction. So the equation for acceleration can be written as A equals delta V, since it is again rate of change of velocity, over delta t, which can also be expressed as a change in velocity can be v minus v sub 0 over t. So v here is the final velocity, v sub 0 is the initial velocity. Okay, so we will proceed directly to the sample problem 3.4. So sample problem 3.4 states that the position of an object as a function of time t is given by x equals 3.5 meters per second cube times t cube minus the quantity of 2 meters per second times t plus 5 meters. So what we are asked for is the velocity for letter A, the velocity and acceleration. So we will give the velocity and acceleration as a function of time, meaning we will provide equations for both the velocity and acceleration in which time is still unknown. And for letter B, we will find the velocity and acceleration at t equals 2.0 seconds, meaning whatever we get from here, or the equations we get from letter A, we are going to substitute the value of t, which is 2 seconds, there in that equation. So let's get started. So for letter A, okay, solution. For letter A, we have V equals, we will start with the velocity, of course. So the equation for velocity is displacement over time, change in displacement over time. So that could be written as delta x over delta t. I have already introduced this equation in the previous video. Okay, so this equation can also be written as dx over dt. This d right here stands for derivative. Since we are talking about derivative, that means we are going to deal with the concept of calculus. I hope you still remember some of the topics we had in calculus, or our basic calculus class last year. So for this, we have, okay, so by the way, I'm going to, since we will be dealing with a derivative, I'm going to introduce to you some of the rules that we are, or the important rules, rules of derivative that we are going to use in this discussion or in solving this problem, which are actually, I think we only have two. These are a bit related to the concept of limit laws, but it actually has a bit difference too. Okay, so let's substitute first the value of x given in here. So d x is 3.5 meters per second cube t cube minus 2 meters per second t plus 5.0 meters, alright, over d sub over dt rather. Okay, so for the rules of derivatives, we'll start with the power rule. Again, I'm only going to introduce the rules that are useful in the calculation of this problem. So we will have first the power rule. So what is power rule? The rule is presented as this equation, or in this form of equation. So if you have here the variable x, so x to the power of n, that means the function involves an exponent. That is why it is called power rule, diba? So in power rule, what you are going to do is to multiply the exponent to the coefficient of your of the term or the function itself. So we will disregard already the d if we start the process. That becomes n. Okay, so after multiplying that to the coefficient, you are going to subtract the value of n by 1. Okay, example. Let's say d over dx is equal to 5 over 6 x to the power of 9. So when we start solving, we have 9 times 5. The coefficient is 5 over 6. So 9 times 5 over 6, we have 45 over 6. And then subtract 9 by 1. That becomes 8. Therefore, the derivative of x is, or the derivative of the function is 45 over 6 x to the power of 8. So this concept will be applied in solving the problem given here. Okay, so we have here the exponent is 3. So I'm going to do this on a separate, another sheet. Right, tama, libog. Second, t plus 5.0 over dt. Okay, so in applying the power rule, our equation will become, or the process will be like this. So we have here the exponent is 3, or its cube. So 3 times 3.5, since 3.5 is the coefficient, we have 3 times 3.5 meters per second cube. What happens to t cube here? 3 minus 1 is 2, so it becomes t squared. Minus, in here we have the exponent of t is obviously 1, an imaginary 1. So 1 times 2 is 2. And then 1 minus 0 becomes, the result is 0. Any variable or any number raised to the power of 0 is equal to 1. So 1 times 2 meters per second, 2 meters per second is 2 meters per second. Okay, so for the third term, as you can see, there is no other variable associated with 5.0 meters. This is where I am going to introduce to you the constant rule of derivatives, which states that the derivative of any constant is always equal to 0. Since we have here 5 meters, or the third term does not contain any variable, meaning it is constant. Therefore, its derivative is 0. So you can put 0 right here or just leave it. Let's perform the operations. 3 times 3.5 is 10.5. Of course, you have to copy the units. T squared, copy, and then 2 meters per second. Is it already simplified? Yes, it is. Therefore, the equation for velocity is the quantity of 10.5 meters per second cubed times t squared, which is obviously not known yet, minus 2 meters per second. This equation will be used later for the calculation of letter B. So we will proceed with acceleration. Acceleration is again the rate of change of velocity. It is written in the equation form as delta V over delta t, and can also be written as derivative of V over derivative of t. Okay. So this equation that we have right here is not only useful for the calculation of letter B, but is also useful in calculating or in getting the equation for acceleration, because we are going to substitute that value in this V right here. So we have 10.5 meters per second cubed t squared minus 2 meters per second over dt. Okay, so again we are going to apply the power rule, because we have here an exponent for t. So 2 times the coefficient, which is 10.5. Let us write it down first. 10.5 meters per second cubed. 2 minus 1 is 1. So I'm going to write only letter t. And we have right here 2 meters per second. Obviously, it does not associate any variable, so it is a constant. And for this term, we will apply the constant rule, which means this negative 2 meters per second here will become 0. So I'm not gonna put 0 here. O pwede sad butangan para makita dyan ninyo. Okay, so we will simplify this value. So 2 times 10.5 meters per second cube is 2 times 10 is 20, 21 meters per second cube t. Alright, so that is the equation for acceleration. So we will proceed with letter B now. Okay, for letter B, we are asked to find the value of the velocity and acceleration given that the time is 2 seconds. So for letter B, okay, so this is the time that we are going to use these equations that we have came up here. So for velocity at time 2.0 seconds, V equals 10.5 meters per second cube times t squared minus 2 meters per second. Okay, we simply have to substitute these 2 seconds here in this equation. So t is 2.0 seconds minus 2 meters per second. Okay, so we have here square of time. Let's copy first 10.5 meters per second cube. We'll do the step-by-step process so you won't get confused. Square of 2 seconds is 4.0 seconds squared minus 2 meters per second. Alright, so 4 times 10.5 is 42. 42. And then what happens to the unit? I'm going to show it here. Meter per second cube times second squared. That becomes okay, cancel. What's left is meter per second. So that is 42 meters per second minus the remaining 2 meters per second. So the answer is 40 meters per seconds. I think it does not coincide with the book, but maybe that is just some typological error they have there. Yeah, so the book's answer is 42 meters per second, and there is actually a locking step right there. I guess that's again a typological error. So the answer really is 40 meters per second. Right, so we will proceed now with acceleration. Acceleration is 21 meter per second cube at So substituting, sorry, I forgot to write this one. Ano? Okay, so 21.0 meters per second cube times, simply substitute 2.0 seconds. 21 times 2 is 42. What happens to the unit is we have meter per second cube times second. Okay, cancel. What's left is, so 3 minus 1 is 2. So we have meter per second squared. Alright, so for acceleration, we have 42 meters per second squared. Okay, so it finally coincides with the book's answer.